let's say this is our car body. The simplest suspension, dating back from the times of horse carriages and stuff like that, is a solid beam, which, as the name suggests, is an axle with two wheels attached to it. The earliest suspension system, and some still do, use leaf springs, but because there aren't any good leaf springs in Lego, I'm gonna use the normal linear coil springs or shock absorbers. So this is how a basic live axle works. As you can see, it's that simple, but it has some issues. First of all, nothing keeps the axle from moving sideways, which is why usually there's kind of a mechanism, or in this case a panhard rod, which keeps the axle from moving sideways. Also, looking sideways, we also usually need some kind of a linkage here to keep the axle from ripping off when the vehicle is going forwards and backwards. Now, while this suspension is really simple and reliable, it has some issues. Along the large number of linkages you need to keep the axle from tearing off, there's also a problem because the suspension is not independent. What does this mean? When this wheel goes up, this wheel goes slightly down. Now that ratio depends on where the springs are placed. The further the springs are placed, the better, but the closer the springs are placed, the more this is noticeable, which is not really ideal if you want a smooth ride. So what do? Well, we can replace the solid axle, take it out, and we can use an independent suspension. So the earliest independent suspensions used pivoted axles like this. Now the suspension can move independently, each wheel can move on its own without affecting the other wheel, but we have a slight problem with changing of the angle of the wheel. That's called camber angle, and as you can see, it's a very drastic change. Now, to reduce this effect, we can increase the length of these arms. So here's a version with longer arms. As you can see, the change of the angle of the wheels is now much smaller, and also the wheels scrub much less sideways than the version before. Now we can also try to increase the arm length past the center point here. Now how do we do that? Well, the solution is quite simple. We take a half axle like this and we offset it. As you can see, the wheel center is offset a stud from the axle. Now we can put this kind of a half axle across the center point and onto the other side of the chassis, and we can do the same thing on the other side. Now this is what we call a twin beam suspension. Now because the half axles are much longer than before, the effects of angle changement or camber are much lower than before, and the whole suspension system behaves more predictably. Now, how do we make this thing steered and driven? Here's one of the prototypes to make a driven and steered suspension. First of all, it's kind of a mix, or should we say a bastardization, of a live axle and a half axle suspension. As you can see, one side has a differential, and this side is connected to the spring here, and it pivots around this point. It's hidden behind the steering link. If we rotate it around, you see this side pivots around this point. The red side is here. The blue side pivots in this internal pivot point here. As you can see, the suspension still has a bit of camber, but it's much lower than when using normal swing axles. Also, because this axle is pivoted in such a manner, we need a CV joint here, which can accommodate the length differences. As the axles move up, the distance between them increases, which is why I used a CV joint here, because it allows the axle to slide in and out. The steering uses linkages like this, and both linkages are centered in one point, and it's activated by a gear rack here. So this suspension is just a prototype to show that it can be done. We can have a driven, steered double beam suspension made out of Lego. But having said that, I am not too keen on using it. First of all, this CV joint is rather unreliable. The Lego CV joints tend to pop out and cannot transmit any high torques. Also, redesigning these axles to add portal gearing increases the problem, because the wheels are now much further from the chassis. The distance between this pivot point and the wheel increases, but it increases in a diagonal manner, which means that the wheels slide out and inside even more. Also, the suspension doesn't have the high travel like my most recent suspension, which I'm gonna use in Oshkosh. As you can see, this is the prototype. Now, if we compare them side by side, if we compare the travel, you can see this axle already bottomed out. The double beam won't go any lower, but the double independent suspension system has a much higher travel distance, which means it can negotiate much better over rough terrain. Also, there are no camber changes with this suspension. The wheels are most of the time always parallel to the body and to each other, which is why I am using this suspension system in Oshkosh and probably several other upcoming projects.